Welcome to the first explainer in our prompt engineering series, How AI Understands Language. We are about to do something absolutely fascinating today. We're going to completely lift the hood on the AI black box. For most of us, interacting with a large language model feels exactly like speaking to some kind of magic oracle, right? You type a question in, hit enter, and this perfectly polished answer just magically appears out of thin air. But here's the secret. There is zero magic involved. It is pure, cold, calculated mechanics. And by the time we wrap up this explainer, we are going to transform you from a casual user who treats AI like a wizard into a literal power user who knows exactly how to operate this highly predictable engine. So here is our roadmap for decoding the machine today. We're going to cover number 1, the illusion of AI. Number 2, tokens and prediction. 3, context and attention. 4, system versus user prompts. 5, crafting the perfect prompt. And finally, 6, mistakes and limitations. Let's just jump right in. Section 1, the illusion of AI, shattering the magic. Okay, to truly master prompt engineering, we have to start by completely stripping away this illusion that there's some thinking, reasoning entity sitting inside the computer. The absolute most crucial point you need to grasp is that a large language model does not know things in the way you and I do. It has no hidden brain, it doesn't have memories, it doesn't actually understand the concepts. It is simply a massive, incredibly complex autocomplete tool running on pure probability. Think about the predictive keyboard on your smartphone. The one where you can just mindlessly tap the middle suggested word over and over to see what kind of wacky sentence it builds. Well, an LLM is essentially a gigantic, exponentially more sophisticated version of that exact same concept. It's processing billions of mathematical parameters just to guess what piece of text logically ought to come next. Moving on to Section 2, tokens, math, and prediction. If it's not a thinking brain, what kind of fuel does this engine actually run on? Because, spoiler alert, it definitely doesn't run on English or Spanish or Python code. It runs on tokens. This is a game changer when you realize it. AI doesn't read words like humans do. It actually chops your sentences into digital Lego bricks called tokens, usually using a fascinating mathematical process called byte pair encoding. For example, a super common word like apple might be compressed into one single token. But a big, complex word like unbelievable, the AI chops that right down into distinct subword tokens like un, believe, able. This is the microscopic digital level where the AI actually lives. It's not reading a beautifully crafted sentence, it's parsing a massive sequence of mathematical IDs. And the process it uses to actually generate text back to you is strictly 100% mechanical. Every single time you hit enter, the machine follows an exact step-by-step auto-regressive loop. It reads your input tokens, passes them all through a massive neural network, calculates probability scores against its entire vocabulary, and then it generates just one single token. That's it. Then it takes that brand new token, adds it to your original prompt, and starts that entire heavy mathematical calculation all over again just to predict the very next one, literally one digital block at a time. It's wild to wrap your head around the fact that when it spits out a massive 5-page essay, it is performing this intense, full-scale calculation hundreds of times a second. If you look under the hood at the math happening here, it's pretty revealing. For every single step of the way, the AI is essentially weighing a massive probability distribution dial before it picks the winning puzzle piece to output next. So let's say it calculates that the token robot is a 50% statistical match based strictly on the previous text. Well, it selects it. The real secret to becoming a great prompt engineer is realizing that whenever you change your prompt, you are directly physically manipulating these statistical percentages. Section 3, context and attention. Now this brings up a really huge question. If the model only predicts one digital block at a time, how on earth does it keep track of a massive set of complex instructions without losing the plot completely? The answer is the context window. Think of the context window as the machine's active RAM. It is a strictly limited workspace. Every single token you feed into your prompt takes up precious space in this window. Let's say you're using a model that has a context window of exactly 8,000 tokens. If you paste a massive document in there and push 8,001 tokens in, that very first token gets pushed completely out of the buffer. The AI literally forgets the beginning of your prompt as that data drops permanently into the digital abyss. But wait, how does it connect the data that's actually inside that window? Well, inside the famous transformer architecture, there's this absolutely ingenious system called the self-attention mechanism. To keep it simple, imagine a highly efficient digital filing system. The AI assigns query, key, and value mathematical tags to your data. Basically, the model asks a question, that's the query, it checks all the labels currently sitting in the window, those are the keys, and then it retrieves the contextual meaning, the value. This is exactly how the engine calculates relevance scores, figuring out that a timed pronoun like it at the very end of your prompt mathematically connects to a specific noun you mentioned 3 paragraphs earlier. Section 4. System prompts versus user prompts. Let's look at how all this theory builds into the actual, tangible controls you have at your fingertips. When you're building AI applications, there is a very strict hierarchy of command. You have system prompts and you have user prompts. System instructions are basically the master controls. They set the core rules, the absolute boundaries, and the fundamental identity of the engine. User instructions, on the other hand, just feed it the variable task or the raw data for that one specific run. So for example, setting a really strong system prompt permanently alters the probability dials for the entire interaction. By commanding it up front to always output data strictly as a JSON object, you are effectively forcing the statistical engine to heavily discount any tokens that look like casual conversation. Why does this matter to you? Well, if you're building an app or trying to organize a massive database, this rigid mathematical fence guarantees the AI won't suddenly start chatting with you, like saying, "Sure, here's your data," instead of just giving you the hard code you need. Section 5. Crafting the perfect prompt. All right, now that we know how the digital gears turn, let's explore the actual insider techniques to drive this engine with some real precision. The very first technique is shifting from zero-shot to few-shot prompting. Look, few-shot prompting is an absolute superpower. Remember, this is fundamentally a pattern-matching engine. Instead of just vaguely asking it for a summary, you provide 2 or 3 examples of exactly what a perfect bulleted summary looks like first. By doing this, you instantly align its probability engine to the exact pattern you want it to replicate. It's like showing it the target before asking it to throw the dart. To consistently get the absolute best results, you need to think of formatting tools like XML tags or Markdown as your structural guardrails. These elements clearly visually separate your raw data from your actual instructions. When you wrap your source material in XML tags, you're making completely sure that the AI's mathematical attention mechanism doesn't accidentally confuse a random piece of text with one of your core commands. It's a surprisingly simple trick, but it dramatically, and I mean dramatically, improves reliability. Another incredibly clever strategy is called chain of thought prompting. By literally just adding the phrase "think step by step" to your prompt, you physically force the model to print out its intermediate steps. Think back to that autoregressive loop we talked about earlier. Generating more tokens along the way literally gives the engine the computational space it needs to process logic. It calculates a much more accurate final answer because it's actively using the context of its own newly generated intermediate tokens to steer that final probability dial. It is absolutely brilliant when you see it in action. Section 6. Common mistakes and limitations. Even with the most perfect instructions, if you misunderstand the machine's mechanical limits, you're going to fail. Let's dramatize a difference here. A vague prompt, like simply tossing in "summarize this data," is basically a recipe for absolute chaos. It leaves entirely too much up to base, randomized probability. The model might give you a poem, a single paragraph, or a 10-page essay. But a highly engineered prompt acts as a tightly wound filter. Using the XML data below, extract 3 bullet points focusing only on financial metrics. See the difference? By specifying the exact source, the length, the format, and the focus, you completely remove the guesswork and mathematically force the model down a single predictable path. You also absolutely need to be aware of mechanical pitfalls, like recency bias. Because of exactly how the attention mechanism scores data, AI heavily favors instructions placed at the very end of a prompt. So always repeat your most critical instructions at the very bottom, because those recent tokens have the strongest gravitational pull on the immediate output. And then, of course, there are hallucinations. Remember, the AI is essentially an eager-to-please crowd pleaser running purely on probability. If you don't provide hard, grounding facts in the context window, the math will simply invent a highly confident, statistically probable lie. It doesn't know it's lying. It's just making the math work. Microsoft's own Foundry documentation says it best, and I think it perfectly encapsulates our entire deep dive today. This quote completely strips away the magic. You are not talking to a person. You are not talking to a hidden intelligence or an oracle. You are guiding a statistical sequence. You are managing tokens, you're steering probability dials, and you are meticulously structuring context windows. So, I want to leave you with this thought. Now that you know the machine is simply predicting the next digital puzzle piece, based strictly on the data boundaries you set, How are you going to rewrite your very next prompt to take control of its probabilities? It is time to stop treating it like magic and start driving the engine. Thanks for joining us for this explainer, and we will catch you in the next one.